Hello and welcome to today's segment of Ars Electronica Home Delivery with a special focus on artificial intelligence. My name is Sandra and you've seen the star of today's segment already driving around here on this course. This is our so-called donkey car, one of the absolute stars of the machine learning studio where we are now. The machine learning studio, some of you might already know it. It's our special workshop area where we can teach robots all different kinds of things. In the case of the donkey car, we taught it how to drive by itself. Although machine learning has another context as well, in a context of artificial intelligence, it's a special type of learning. But that would go too far to really explain that in detail. We will do that maybe in another segment. What we did here with this donkey car, I'm going to show you, is something very special. So this software used to create this amazing project is open source. So you can actually build a car like this at home if you want to. So all you need are the parts, for example, the wheels and also the motherboard, which is a Raspberry Pi in this case, and of course an energy source, 2 energy sources actually, so that the car will run. And if you have a 3D printer at home, you can customize it. All the parts here, the frame, for example, was 3D printed in-house, and you can even add your own spins maybe. You can add whatever you want. In this case, we have a little frog here to drive our car. Yeah, how does it work? This car doesn't just come out of the box, so to say, and drives by itself. No, we had to train it. What does it mean? What does this training involve? First of all, we need an PlayStation controller, as you see here. So it's like a normal toy car you can drive around with a joystick, so to say. But what's special about this car is it has a camera at the front, and with this camera, it takes pictures, 10 pictures per second to be precise. And you can see on the screen over here what the car sees right at this moment. Or at least you should. I moved the car. Oh yeah, now it works. Perfect. So when I move the car around, you see from the car's perspective. And when I put it on this track you see on the floor and drive it in not self-driving mode, but in training mode, I drive it around. And this car takes pictures. The camera takes pictures of the track and of the surroundings and saves those pictures. And over time, I think we have 8,000 pictures for this special model to train. And now we can switch from training mode to self-driving mode. And when we do that, what does the car do? Well, it looks back at the training data where it was, for example, in a position in the room. And if the position is not the same anymore, it tries to find similarities. For example, a wall or boxes or screens. So it tries to find what it knows and orient itself that way. And it's also important how fast it was going, so how much the throttle was activated, and also the angle of the axis of the wheels was important. So it knows at this particular curve, for example, my axis was turned like this, for example. And that's how it's able to drive. It's not perfect because this is just a very simple version of self-driving cars, but one you can build at home, which is pretty cool. But if you think about self-driving cars on actual roads, of course, they have many sensors, many other sensors as well to tell them where to go. Otherwise, this would be way too unsafe. But for our purposes here, it's more than enough. And we also do workshops here with this type of car. Let's drive around a little bit more and see if we can find a way to, let's put it like this. If it can find its way on the track here. You see, it's not perfect. That could have many reasons. One reason might be because I'm standing very close to it. I was, of course, not present when the training data was recorded, And the car does not normally have a pair of feet standing there. Oh, it's doing pretty well, that's nice. But think about a large group of people. If they all stand around this track, watching this little donkey car, it does not have the same references as it had with the trainings data. What does that mean? Well, the trainings data records everything, also the screens, for example, on the walls. And if there are people blocking its view on the screens, it might not know where it is in the room. And it might not be able to follow the track anymore. But right now, it's doing really well. Okay, thank you. A little car wants to be in the front and center of the camera. Let's pick it up again. So I want to show you how this car sees the world. So let's switch to another perspective here on the screen, where we see the screens that it recorded all the way around in the main gallery have a different color shade. They are much brighter, and it also knows, okay, there's a screen, I know I've been here before, and I can orient myself with it. As it does with the lines on the floor. So it knows, okay, I know those lines, I know I have to turn my wheels to the right or to the left, or I have to go straight or faster or slower, depending if there's a curve or a straight. So, pretty cool project already. Okay, so those cars, like I said, you can build at home, you can customize them, and I would recommend a 3D printer. Or if you want to try them out for yourself here before buying them, of course, come here to our machine learning studio, where we have specially trained tech trainers to help you along with this project. And you can also book workshops here, where you learn how to train machines, how to build it yourself, and lots more to do with robots, cars, and much more. So that's it for today's segment for autonomous cars. Thank you for tuning in, and see you at the next segment, which will be Deep Space English highlights. Thank you very much, and goodbye.